Hello, I'm Jennifer Saratan. Welcome to Project-Based Learning Science for grades 3 through 5. This video will give a basic overview of the class, what to expect as a parent, and what kind of role you're going to play in providing this course. What is the role of the student and what's my role? I'll also provide some resources and acknowledgments and then clarify how it is that you need to hand in assignments so that students can be properly assessed for their progress in the course. Again, I'm Jennifer Saratan. I'm a science and health teacher. I'm a master trainer for Garden of Learning, and my contact information will be on the website. So please don't hesitate to refer to the website for future videos, other helpful links, and a place to upload your assignments. So let's talk a little bit about the course. The overview of this course, basically I want to be really clear that this is a course that is project-based in the sense that there's not a lot of time spent in doing reading and worksheets. Most of what you're doing is actually following through on doing some kind of activity, and the activity in and of itself is the assessment. So by documenting the discussion you had with your student, or taking a picture of the model that you made, or any of those kinds of things is usually how progress is assessed in the class. So there's no tests, there's no quizzes, there's just a lot of fun. So let me tell you a little bit about project-based learning. Project-based learning, the units are designed to have a lot of hands-on projects. Students will be working their way through a series of activities that give them the opportunity to think about what they've learned. Each unit is focused on a driving question. The driving questions are the point of the unit. All the things that the students are learning in the unit are to help them to answer the puzzling question or to solve a problem, a real problem possibly in the real world. Hopefully by the time they are finished with the unit, they'll have learned some information and skills so that they can do some of the projects that offer something useful to themselves, to their family, their school, or their community. And that's kind of cool. In these units, the parent will help the student get started by understanding the background information and the object of the lesson. Then the parent will guide the student through the activity and help the student draw conclusions. So have fun together. I recommend as a parent that you spend some time listening to these introductory videos, as well as looking through the box and getting familiar with the contents. Then when it comes time to watch the daily videos and we explain what materials you need and the background information you need, you'll be prepared to then get your students started, give them the information that they need, and you'll have all the materials on hand. There are art materials in the box, there are planting materials on the box, there are physics materials in the box, there are some things that are not in the box because there's an assumption that they're pretty common to have in the household. So you may need to gather a couple of those items up. So just giving you fair warning so that you can make sure you have what you need well before you want to sit down with your student. And that will save you some time. Also, some of the materials, we have a little bit of art materials, but you may want more art materials because creativity is really important. It's actually part of science. So interestingly, you'd think art and science are opposites, but really scientists are incredibly creative. And you'll find some units where we do a lot of art because it really is part of science. So make sure you have plenty of art materials on hand. If you don't have enough, we have them in the box, don't worry. But if you have some, please make them available so the student can really open themselves up and be fully creative. It's estimated that each of the projects should take about 1 to 2 hours a day. So you can take longer or shorter. If 1 hour is too long, I'd be happy to talk with you about ways to make things more efficient. If you're having a great time and your student is really engaged, you can take 2 hours or more by getting involved in some of the supplements and some of the extension activities that will be offered. But the idea is you really want to thoroughly take the time to introduce the student to the activities, to fully do the whole activity, and then to process it at the end with the discussion or whatever the instructions are for that particular lesson. Because the exploration and the inquiry or asking of questions and exploring those answers is what science is all about. So you'll find that each science activity has something that you're going to hand in. It might be that you did a project and you take a picture of it and you upload that picture or give that picture to your visiting teacher. It might be that you do a worksheet that shows the data that you collected and you hand that in. It might be that you write a paper. At the end of each unit, there might be a major project where you're putting together a lot of what you learned, and you'll hand that in. So all of those things can be uploaded on our website, and directions for that will be included. Or if you can't do it on the website, you're welcome to make a hard copy in paper or some format that the teacher can collect and give it to me to assess. So your job as the parent is to get the information the student needs from the video and from the box to orient them and give them the background knowledge they need, to guide them through the activity itself, and then to make sure that that information is documented and passed on to me so that I can do my job, which is to support you, not only in carrying out the activity, making sure you have all the materials you need, make sure if there's any questions that you have are answered, but then to also assess the student's progress. And the student's role is to be engaged, have fun, ask questions, and try to find the answers. The idea is to have a chance to really think about each of these activities. None of them are really deep information. It's more the exploration process, and that's what science is all about. It's inquiry. And that's what project-based learning is all about as well. The idea of project-based learning is that you're really trying to use skills as a scientist and as a 21st century community member. So there'll be some core basic information that the student will be learning about the natural world, about life sciences, and about physics and physical sciences like magnets and energy and light and things like that, as well as about plants and animals. But they'll also be developing skills like problem solving, critical thinking, communication, and all of those things are really important, not just in science, but in life. In-depth inquiry is another real important part of project-based learning, where students are engaged in a rigorous extended process of asking a question, using resources, and developing answers. And this is all using that idea of the driving question to seek out some answer to a larger problem. There are other pieces that might be part of it as well, where you learn to start and revise projects and make them better, as is the case with the final project in the physics unit, where the students were actually going to create their own tool. And there may be other things where students have a chance to present something, like their information about the animal that they created and presenting that to another person. So all of those things are part of project-based learning and are a perfect fit for a science curriculum. The first half of the year is called the Introduction to Life unit, and this unit should take you about the first semester to complete. And basically it's talking about plants, animals, their adaptive qualities, and getting into ecosystems and things like that. So basically exploring the natural world of life, or biology, life sciences. And the second half of the year is Introduction to Making and Moving. So how are things made, a little bit about engineering, and then how do things move, a little bit about physics. And that should take you to the end of the school year. Each unit has a major project at the end and lots of mini projects along the way, as we talked about earlier, because every day is another little activity. So the projects are going to come from the following sources. First of all, there'll be some background reading from a book called The Science Magnifier, and this is just a little mini textbook that has a lot of background information. It's very short and very sweet, just gets to the point, using some cartoon characters as the guides through the book. The chapters just are only a couple pages long with lots of illustrations that just give you the meat and potatoes, or the basic information. The idea is that if you have the general idea, then when we get to specifics, that will come up in the video that I present to you and in the lesson that you're carrying out. Then each of the lessons and activities, I'd like to thank, as part of my acknowledgement, all of the teachers that have contributed to these resources. So a lot of my activities and lessons have come from teachers who have been willing to present their tried and true lessons on the World Wide Web. And there's also a resource called TOPS, which is by Ronald and Peg Marson. They have compiled a whole series of science activities for students using minimal science equipment to make sure that science is accessible to all students throughout the whole world. There's also 3 books that are compilations put together by federal agencies, nonprofit organizations, and teachers, each with a different theme. And the idea is that they're curriculum guides for grades students of all ages, and they have the full information of the background information, how to carry out an activity, and the kinds of things that you're going to look for the student to have completed, as well as some variations and extensions for students with different interests. One of those is called Project WET, and this one is the newer version, though a lot of my projects are coming from the older version. Another one is called Project WILD, and this one has mostly to do with plants and animals, whereas Project WET is, guess what? It's from water. Everything having to do with water. It's a wonderful resource. And last but not least is the one called Project Learning Tree, and this has to do with agriculture and forestry. These people have been kind enough to offer that anyone who works their way through this class and watches the videos and learns how to do the activities that come from this source as part of the course, you will actually get a copy of Project Learning Tree for free if you choose. So by the very nature of the fact that you've worked your way through this course and learned how to do the activities in this course that come from this book, you now understand how to use the curriculum guide, and they will give you a copy for free if you request it. So if you'd like any of these copies or the Living Wise by the Energy Trust, which is part of the final unit that we do, please let me know, and I will make sure that you can get some copies of those. So from now, I just want to say thank you for joining me. Thank you for listening to this introduction. Hopefully it's been helpful, and we'll move on to other videos that will give you some more in-depth information, in particular about project-based learning or how to hand an assignment in, and then we'll go on to do a daily video that will help you orient yourself and get your students started for your daily activity. So welcome, thanks for joining me, and I'll see you in the next video.